Hi class, this week we are going to continue with a new chapter, chapter 6, gradient and area under a graph. Right, I will also give you handouts. You print it at home and then we are going to finish the question together. Okay, chapter 6, gradient and area under a graph. Okay, the first 6.1, quantity represented by the gradient of a graph. Do you remember how to find gradient? Is related to gradient. Gradient, you learn this formula in Form 4, during Form 4. Gradient of the straight line. What's the formula? Okay, look at here. Gradient, remember, you need 2 points on your graph. Let's say this point and this point. You need your x and y coordinate, x and y coordinate. Then what do? Take the 2 points, you use this formula. y1 minus y2 over x1 minus x2. That is your gradient. Okay, the distance time graph. So this chapter, they are going to teach you how do you analyze the graph given to you. Okay, this is a distance time graph. Distance always at the y-axis, and then your x-axis will always be your time, right? So you look at this graph, you see, this is a straight line going up. What does that mean? What does OA means here? This is the time. As the time goes by, and then your line representing that your distance is increasing. What does that mean? Means that the car, let's say I draw a car here, means that the car is moving. Because as the time goes by, your distance is getting higher, getting further away, more distance, jarak, distance. Okay, this is OA. Okay, look, okay. And then from A to B, it is a horizontal axis like that. So what does that mean? This straight line here from A, B. As the time still going by, does your distance increase or is on the fixed value here? This AB is a horizontal line. It stops at this distance, right? It's not moving back or not moving down. What does that mean? Means that is your car moving? It is not moving. We call it stationary. Fixed. Tidak bergerak. Your car is not moving during this time here, from this second to how many seconds here. Okay, after that, after you stop for a while, you are going down the straight line. The car is now going down. As the time goes by, your distance, okay, this is 0 until the distance here, it is going down. What does that mean? Is your car still moving here for part BC here? Your car is moving because your distance is changing for every second, right? But why is it going down? Why is it not going up? If it is going down, remember, yeah, it means you are still moving, but you are going back to the reverse back. You use the same route, you go back to the original starting point. Let's say here, this is your starting point. You want to go to the clinic. Okay, you go to the clinic, and then you stop a while at the clinic, then you patah balik, return. It is represented in this straight line here for this case. Your starting point, you go to the clinic and then you stop for a while, then you go back. That's why it is going down. It means opposite direction. Okay. So before I explain the gradient, okay, look at this. They say the gradient of the graph represent speed. The gradient of these straight lines will represent the speed of the car. I want to show you what is the logic behind it. You learn speed, the units for speed in your physics or science subject. So this is the units for speed. Meter per second, right? Or we can write as meter per second. You will also see kilometer per minute. Depend on the question. So what does meter means? Meter means your distance travel. How far have you gone? Over second represented by time. Distance over time. Remember, S speed equals to distance over time, right? Okay, so we come back to our graph here. Distance is this y-axis, right? Distance is your y-axis. Over your time is represented by the x-axis, y over x. And okay, then you refer to your gradient. You see your gradient formula, it is y1 minus y2, means that if these 2 points are, you're using these 2 points, y1 here minus y2 is the distance traveled over x1 minus x2. This is x1, okay, the x here, this is x2. So x1 minus x2, this is the time taken for this straight line. So you put this, you apply this equation, you solve it, you will get the speed of your car, right? Okay, so here, distance traveled is determined with reference to the vertical axis. Vertical axis is which axis? Vertical axis is this axis, huh? How far have you traveled? You just refer to the values here. Okay, here. So they sum it up for you already. Gradient of OA, O to A is positive. Means that your speed is in positive value. Then second one, gradient of AB is 0. Means that your speed equals to 0 lor. Means it's not moving at all. Maksudnya tak ada kelajuan langsung. Then gradient of BC, if you use this formula, you will also get a value, but it will be in negative. -2, -5, according to the points given to you. So what does that mean? If the speed is negative, means is moving back to starting point. Okay, negative value here. This is positive gradient, negative value. Come, we will try some examples here. In SPA, it will come out in paper 2. One question is around 4 to 5 marks. So you have to do practice for a few questions here, and then you're going to do your exercise later. Okay, look at this. First of all, I want you to see what graph is this. Look at the units represented. It is a distance and time. Means this is a distance time graph on and of an object. You don't know what object is that, huh? Using the graph, find its speed during the first 3 seconds. Okay, keyword here, first 3 seconds. Speed. Whenever you are given a distance time graph, okay, no matter how does the graph changes, you must remember you want to find distance. You want to find speed. Speed is distance over time. Then look at this keyword here, the gradient of the graph represent speed. You want to find speed, you find the gradient. Okay, so to find gradient, you need 2 coordinates here. Okay, 2 points. What do they want? During the first 3 seconds. First 3 seconds, you have to look at the time. First 3 seconds is where? 0 until 3 seconds here. Means they want you to find the gradient for this line, AB. Right? So you need 2 points, these 2 points, you take the end point because you know their coordinate. This point here, point A, what is the coordinate? What's your x, what's your y coordinate? Your x coordinate is 0. Your y coordinate is 2. B, what is your x and y coordinate? Your x coordinate is 3. Your y coordinate is 8 here. Okay, so we're going to try this. You want to find the speed equals to y1 gradient, so I take y1 minus y2. Which one is your y1? Which one is your y2? Where's your y1, y2? You can let this be y1, you can let this be y2, or the other way around. Doesn't matter, you will get the same answer. I let this be y1, this one be my y2. Up to you, huh? So please don't make the mistake of taking 3 and 0 first. You must remember you take the y first. 8 minus 2 over x1 minus x2. Where's your x? If let's say you let this be y1, this must be your x1. You cannot let it be x2. So this is x1, this will be your x2. So x1 minus x2, 3 minus 0. 6 over 3, you get a 2. So speed, what is the units? Take this, meter over second, right? Meter per second. Or meter second negative 1. This is a first. Okay, next one B. Its speed during the last 4 seconds. Where's the last 4 seconds? Total time is 10 seconds. Where's the last 4 seconds? Means starting from where? 10 you minus 4, you get 6, right? Here, this part would be your last 4 seconds. So for this part, for this time here, you look at your graph. It is going down. What does going down mean? What does the speed means to you here? Okay, at first, it's going up means it's moving lah. The car is moving at how many speed here? The speed is 2 meter per second, moving like that. And then from B to C is a horizontal line at 8. Means it's not moving at all because the distance still remain at 8. Then it go down until here, until 0. So I want to ask you one question. Is it that the car moved back to the starting point? Starting point is here, but it's going down. No, right? It's not returning back to the starting point. But in fact, after going back to the starting point, it moved further away lagi. Further away 2 meter here. So by right, the car should stop here to go back to the starting point, but it still continues 2 meter away lagi. Okay, so now they want you to find the speed. Remember, whenever they ask for the speed, you find the gradient. To find gradient, you need 2 coordinates here. Let's say this, what is the coordinate for point C? 6, 8. This one would be 10, 0. Right? You want to let which one be your y1? Up to you. Let's say if I let this be my y1, this one will be my y2. 8 minus 0 over, if this is a y1, this would be x1, x2. 6 minus 10. 8 over negative 4 equals to negative 2 meter per second. The speed, you see the difference between them? One is positive, one is negative. Negative only means that it's going back, moving back to starting point. But the speed is still 2 meter per second here, right? Okay, then we continue with C, last one. Whenever you see the keyword average speed here, please come back here. These are the notes that you have to write down yourself. Average speed maksudnya secara purata, right? This is 2, this is 0 speed, this is negative 2 speed also. But secara purata, averagely, what is the speed of that car? So if you see the keyword average speed, you are going to use this formula straight away. You take the total distance, no matter what is the speed for each section here. You take the total distance traveled over total time taken. So first, you have to find out what is the total distance. Okay, we look at the first part here. From 2 meter to 8 meter. So you cannot just take 8 meter here. What's the total distance traveled here? You take 8 minus 0 because you didn't start from 8 minus 2, sorry. You take 8 minus 2 because it did not start with 0. It's not 8 meter here. It is actually 6 meter here. So average speed equals to, I take 6 meter plus with total distance, right? This one, any distance travel? No, 0 distance. So just continue. From C until D, what is the total distance travel? You come back to your y-axis. It's 8 until 0, right? So total is 8. Over, what's the total time taken? 0 to 10 seconds. 1.4 meter per second. Average speed is 1.4 meter per second here, right? Then we continue. One more question, example here. Distance time graph again is going up, then going up again. You see the slants, the kecerunan dia. The slanting of these two lines is different. Means which one? As the time goes by, their speed is different here. The diagram shows a distance time graph of a bus traveling from a bus station. Means that they start from here, 0 second bus station, and then to factory P, and then to factory Q. Go factory P, then go factory Q. The graph OA is here, represent its journey from the bus station to the factory P. So this one, they stop at factory P. After that, line AB represent its journey from factory P to Q. From P, go to Q, factory Q. Find the distance from P to Q. Okay, this one not difficult, it's very straightforward. Your A, what is your answer? Distance is already on your y-axis, but it's not from 0 until 50. From P to Q only. P to Q, what is the distance between them? Look at your y-axis. From 20 to 50, 50 minus 20, 30 km. They are using kilometer here for this question, right? So this is your answer for A. Continue. B. Calculate the speed in km per hour of the bus from P to Q. Take note, huh? Tricky question here. It will also come out in SPM. They want you to calculate the speed, kilometer per hour, but your graph here is minute, right? So later you are going to change minute to hour. Then only you divide. How? Calculate the speed. Whenever they ask about speed, you find the gradient from P to Q. P to Q. P to Q. Gradient. At first, what do? You take your y1 minus y2. This is 25. 25, 20. This is 45, 50. 50. I take this one y1 minus y2 over x1 minus x2. .5 kilometer per minute. Right here, I suggest you to write down the units. This is your distance over your time minute here. Okay, you know you have to change it, convert to km per hour, huh? We are going to continue first. We are going to solve this. This is 30 km over 20 minute, but you don't want minute. You have to change. How to change then? To minute here. You learn this in primary school. When you want to change from minute to hour, you divide by 60. So 20 divided by 60. What do you get? You get a 90. 90. It become, this one become hour, this one is still km, it become kilometer per hour here. So this is your answer for B. Then we proceed with C now. Calculate the average speed. Still the same, they want kilometer per hour of the bus for the whole journey, average speed. Whenever you see the keyword average speed, you remember this formula, total distance traveled over total time taken. So average speed equals to total distance travel. What is the total distance travel? So 0 to 20, stop a while, then go to 50, right? So total distance 50 over total time. What's the total time? 45 minutes, but this is 45 minutes. You want to convert to hour, you divide by 60 here. Solve that first. 50 over 45 divided by 60. 3 over 4, you leave it as fraction. Then you use a calculator to help you. 50 divide by, okay, or you use fraction. 50 over 3 over 5. 3 over 5. Everything you just key in nicely into your calculator. You get a 66.667, round it to 2 decimal place. 66.67 kilometer per hour. This is your answer for question example 2. We are going to do the exercises here. I can show you one more example. Question 2. Here, you look, all the other graph you have go up, stationary go down. But how about this one? This is straight away going down. From 50, return lah. It's like you go to that point, and then this graph is from that destination you go back. 50, then go to distance 30, then stop a while, then go to distance 0. Go back to starting point. The diagram shows the distance time graph of a bus over a period of 60 minutes. Calculate its speed, kilometer per hour, during the first 20 minutes. First 20 is here. First 20. Speed means they ask you to find the gradient between these two. So these 2 points take the coordinate. X coordinate is 0, Y is 50. How about this? 20, 30. So A, the speed equals to y1 minus y2, 50 minus 30 over 0 minus 20. You get a negative value here. But first of all, before you use a calculator to get the answer, this is in km and minute. You don't want minute, right? 20 km over, this is a negative, can put outside. 0 minus 20, you get a negative 20. So you put outside your negative. 20 minutes, you have to convert to hour. You divide by 60. 20 over 60. You get a negative 60 kilometer per hour. That is your answer. Negative, because it's going down. Gradient is negative. B, you can try yourself. I leave a blank here. I want to show you. See the length of time in minutes now that the bus is stationary. Which part the bus is stationary? Means it's not moving. Means the distance is not going down or going up at all. Here, this part stationary. Length of time in minutes. How many minutes here? Look at your x-axis here. It's from 20 minutes to 40 minutes. Total, how many minutes here? You take 40 minus 20. 20 minutes stationary, not moving. D now. Average speed for the whole journey. Average speed, the same thing. You need to find the total distance over the total time. So what is the total distance? Average speed, total distance from 50, then go to 0 distance, means it's 50 lah, over time is 60 minutes. 60 minutes is how many hour? This one we know, right? 60 minutes is 1 hour, so divide by 1 hour straight. So the answer is 50 kilometer per hour here. Okay? You can try the rest yourself. Then we are going to the second part. There's only 2 parts for this chapter. Next graph that I want to introduce you is the speed time graph. It's different from distance time graph. Look here. Look at the unit. It's represented by speed over time. So later when you find the gradient of this speed time graph, it will represent different things. First, you see, the gradient of the graph represents the rate of change of speed. Rate of change of speed, you learn in physics or your science also. Rate of change of speed. The speed is changing. We call that acceleration, pecutan, or deceleration. Deceleration means it's going slowly and slow down. Accelerate means it's going, the speed is increasing, speed increase. Deceleration, going down. Okay, I want you to be logical, Speed over time. As the time goes by, your speed, because it's representing speed, your speed is increasing, right? Your speed is getting faster and faster. We call this acceleration. Then from A to B is a horizontal line. Does this horizontal line means that your car is not moving at all? For this case, the speed is at a fixed value here. It means it means the car is still moving, but it's not pressing on the pedal, it's not pursued. Okay, using the constant speed, the same speed. And then just as the time goes by, and then when it goes down, means your speed is decreasing, berkurang, means that it's decelerating, means that it's pressing against the brake now. It's going to slow down until zero speed, until it stops here. Okay, so here, acceleration, the unit for acceleration is meter per second square, right? The units for acceleration, you will see meter per second square. How do you get this? If I say I want to find the gradient of this OA, still the same, y1 minus y2 over x1 minus x2. y1, y minus my y2 is your here, this part, the difference here, right? The change here. What is represented by your y? Speed. The unit is meter per second, isn't it? So I take meter per second here. Your y is represented by meter per second. x1 minus x2 is represented by your time over s. So when you solve this, it will become meter per second square. This is how you get your acceleration. This is why your gradient equals to your acceleration here, right? And then the next one that you have to remember, okay, for speed time graph, you need to find the area under the graph. Area under the graph means your graph is like that. What the area under your graph represents the distance traveled. For example, you want to find area, right, for a rectangle like that. Length times width. Length, what is your length? Length is here, length. Length is represented by what unit? Meter per second again. Times with your width. Width is represented by your time times s. You cancel, it becomes meter. So this is why your area is representing the distance traveled. Right? We try one example here. This is a speed time graph, so you have to remember one thing, the gradient will equals to the acceleration. The area under the graph will become the distance. Depend on the question, what do they want? Speed. Look at this first, analyze it. From 60, then drop to 30 on the first 4 minutes. Then it remained at 30, the speed. The car is still moving, but at 30 km per hour, then increase, means it's getting faster, moving faster. So look at this question here. The diagram shows a speed time graph of a car during the period of 20 minutes. Calculate the distance in km travel at uniform speed. Apa itu uniform speed? Where? What do they want? Uniform speed means the speed is uniform. Rata, uniform. Wait, which is where? Here lah. This is the uniform speed. It's not going up or going down. The distance travel. Distance. What is the distance travel? How to find distance? Remember the formula again. To find the distance, find the area under the graph. You only want to find this part, right? So you only find the distance travel. You only find the area under this graph. You don't go and find the rectangle here, the triangle here, and the triangle here. So if it's a rectangle, then the formula to find area is very simple. It's a length times width. What is the length here? The length here is, according to this unit, it is 30. 30. To find distance equals to 30 times width. The width, minute, 4 to 14. So what is the answer here? 14 minus 4, 10. 300 km. B now. The total distance in km. Oh, okay. You have to see properly this question. The speed here is km per hour, but the time here is according to minutes, so you cannot just do this straight away. You have to change it to hour now. So we know this is represented by minutes, means this is 10 minutes here. But when you multiply, the unit must be the same. It's no longer times with 10. This 10, how to convert to hour? Divide by 60 here. So 300 divided by 60. You only get 5 km here. Okay, take note, you have to refer to the units. Then we see they want the total distance in km traveled by the car. The total distance, how to find distance again? For this speed time graph, distance, find the area under the graph. Distance, total distance means they want throughout the whole journey. What is the total distance? We already found this, right? It's 5 km. Next, what do we need to find? We need to find this part and this part. Let's say A here, I put A here. I put B here because we already found this part A and B. We want to find area under B. So I have to think, what shape is this? This is a trapezium, right? Area of A, area A. Okay, flashback. What is the area of trapezium? What is the formula there? This is